Okay, so this is a topic that we've covered before, but it also comes into this unit. So we'll do it. We did this back in the very beginning when we were talking about food webs and food pyramids, but it also comes into this unit here. So let's get on it. So POPs and bioaccumulation. So a POP, that stands for persistent organic pollutants. Now these are synthetic carbon compounds, and usually they involve carbon rings, like here. Okay, these are known sometimes as benzene rings, and so they often contain like chlorine, and they have a tendency to be very durable compounds. Once they're made, they stay made for decades. That's since they're called persistent. And the problem is because they are able to get into to dissolve into fats and become integrated into the tissues of living organisms, they have a tendency to both bioaccumulate and biomagnify over time. So we're just going to go back over that one more time. As I said, we've covered this earlier in the year, but we're going to do it again here. Okay, so there's three main types of POP, or persistent organic pollutants. There's organochlorine pesticides. You don't need to know that word, but you do need to know the term DDT, obviously. So DDT is a classic example of an organochlorine pesticide. Here's an example of the DDT molecule. And these things are used primarily as pesticides. And it's worth noting that not all pesticides are POPs. In fact, we don't use them anymore. Uh, but anyway, but that was a category of POP. Another one is polychlorinated biphenyls, or PCBs, which we see here. That's another important category here. And these are used in industry, for a number of industrial processes, like say solvents. And then there's dioxins, which are basically byproducts of industrial practices of burning things. And so we don't mean to make them, but they get made. And you notice they all have that ring-shaped structure, and they're very durable things that get into our tissues and then magnify when they do. So they have a very long half-life. So because of this ring structure they have, and by having a long half-life, that means that they have the ability to accumulate over time. So if they broke down quickly, they wouldn't be a problem. But they're very persistent, hence the term persistent organic pollutants. So just to give an example of this, so DDT, it was very popular insecticide used for killing mosquitoes. And to be honest, it still is used in some cases when there's a bad malaria outbreak. People get permission to use it still. It's very effective at killing mosquitoes. But even though it's no longer used for the most part, it still circulates in the environment quite a bit, because even though it was built, say, in the 1950s, these compounds, they just don't break down very easy. So, and we're talking like decades later, these things are still around. That's what I mean by persistence. Now, because they persist, because they don't break down, they tend to get carried a long way. So just because you live in an environment that doesn't use DDT, you're far from any source of it, that doesn't mean that you're safe from it, because it can be carried literally all the way across the globe, by wind, by rainwater, uh, by different mechanisms. So these things have a tendency to travel a long way, and so that it becomes a global problem. So if any country's still using DDT, it's still a problem for everybody, not just for that country. Now, the United Nations saw this problem looming, and they decided that they needed to try to do something about it. So, in 2001, they authored a document called the Stockholm Convention on Persistent Organic Pollutants, and it went into effect in 2004. And pretty much every country in the world signed on to it. And among the things it did is it basically said, look, there's this dirty dozen, we'll call them, POPs that we are not going to nobody's going to use anymore. And you do not have to memorize them, but I will just point out they come in. There's three broad categories. There's pesticides, industrial chemicals, and then byproducts of industrial chemicals. And so the pesticides, the one you probably need to know of all of them is DDT. Chlordane is another one that gets talked about a bit, but you do need to know DDT. Industrial chemicals, hexochlorobenzene, benzene is a word for that carbon ring, polychlorinated biphenyls, or PCBs. You definitely should know the word PCB. And then there's the byproduct compounds. So these generally are dioxins and PCBs, but dioxins are a very important POP that are of concern. And again, these are not ones that are made intentionally, but they are a result of um, uh, usually of combustion that results in the formation of these compounds. So here's what's wrong with these compounds. Okay, here's why they made the Dirty Dozen list of the Stockholm Convention. Is first of all, they're toxic. Right? They kill that. Pesticides is what they're designed to do. But basically, these things kill mainly by being almost all of them are immune disruptors. So go back and look at that uh, document to see what all it is that the endocrine disruptors do. But basically, they either block or activate sites that hormones are supposed to activate. Uh, and they're very durable. So once they're made, they stay made, and that allows them to travel long distances. So they become very pervasive in the environment. And worst of all, they tend to bioaccumulate. They're fat soluble and they're long lasting. So that once they get into our fats, into our tissues, they just stay there, and we get more and more and more of them. And then they also magnify as they move up the food chain, because if a fish has 1 gram of it in it and you eat that fish, now you've got 1 gram in you, but you're going to eat fish every day. So over the course of time, like each fish might accumulate 1 gram over the course of its life, but you eat a bunch of fish and now you've got hundreds of grams in you. They can accumulate like crazy amounts, like hundreds of millions of times more than what they are in the environment. So let's just talk about bioaccumulation. Okay, and again, I know we've talked about this before, but thanks for watching. Okay, so bioaccumulation is the buildup of toxins over time in an organism. So let's say you start off, you have no DDT in you. As you go through life, you get more and more of it in you. We call that bioaccumulation. So in order to bioaccumulate, a substance must be durable, like not break down, have what we say is a long half-life. And it also has to be fat soluble. If it's water soluble, it just pass out of your body. You'll excrete it in your urine. But if it gets incorporated into your tissues, if it's lipid soluble, fat soluble, that's when we've got a problem. So the POP is not the only thing that bioaccumulate. Sorry, my nose is itchy. POPs do. So DDT, PCBs, dioxins, those are the 3 biggies you need to know about. And these come from basically agricultural, in the case of DDT, industrial in the case of PCB, and dioxins as a result of as a byproduct of agricultural practices. But there's 2 others you should know about. One is mercury, and the other one is lead. So the main source of mercury is the burning of fossil fuels. It also comes from mine and some industrial wastes. And lead, again, comes from burning fossil fuels and mining and industrial waste. So we're going to look at each of these in turn just to get a sense of what it is that they do, okay? All right, so let's just I like this graphic here. I put this together myself today, okay? I took a picture of the human body and then added my little red dots. Okay, so bioaccumulation is the buildup of toxin in an organism over time. So this is separate from biomagnification. Bioaccumulation just means that if I take in one of these compounds, lead compound, mercury compound, POP, that every time I bring it into my body, it stays there. So over time, I get more and more and more of it in my body. So it is accumulating in my body over time, and eventually gets to a point where it's causing some significant health problems. Unfortunately, one way it gets passed along is into infants is through breast milk. So as mammals, we have a tendency to begin our unfortunate foray into bioaccumulation very early in life because our mothers unintentionally pass it to us in milk, which has lots of fats in it. And then if the mother has accumulated a lot of these toxins, she will pass it on to her children. Now, biomagnification is slightly different from bioaccumulation, if you recall. So bioaccumulation just means that over time, the amount in an individual's body goes up. Biomagnification has to do with passing things from one trophic level to the next. So every time you start off with small amounts in lower trophic levels, and each time you go up a trophic level, this organism is going to accumulate everything it eats has this in it, so it's going to accumulate lots of it that way. But then when this one eats it, it's going to accumulate a bunch of these. So basically, the levels that go as you go up, as I said, they can be thousands of times, millions of times, hundreds of millions of times higher concentration here than what we find in the environment itself. So that's how bioaccumulation in individual organisms leads to biomagnification as we move up in trophic levels. So let's just look at 3 or 4 examples here. Okay, so PCBs, okay, polychlorinated biphenyls. It's an industrial pollutant. We're no longer allowed to produce, make them. Stockholm, they're banned by the Stockholm document, but they're very long lasting, right? So once they get made, they stay made. So what happens is there's a small amount of them that still persist in the water. They get taken up by plankton. They get eaten by zooplankton. Then they get eaten by primary secondary consumers and tertiary and so on, and they tend to accumulate until we have now like orca whales have these deadly levels of these toxins in their body because they're durable and they accumulate and magnify. DDT is a really famous one. So DDT is really what brought this whole concept to light in the book Silent Spring by Rachel Carson. You should probably know about this book. It's that important. So one could almost make the argument that this book by Rachel Carson, Silent Spring, really began the world's wake up to the problems of environmental science and the dangers that are posed by messing with ecosystems without knowing what you're doing. So basically, DDT is a very, very effective insecticide. It's great at killing mosquitoes. Unfortunately, what happens though is it is very persistent and quite toxic. And so what happens is you have very, very trace amounts. Look at this, like 0.0000003 parts per million in water. But it gets taken in by phytoplankton, it gets taken in by zooplankton, and then by the time you get to the apex predators, like the osprey that's eating this fish, you can have 25 parts per million. So look at the difference between this. I mean, that is a huge, that's a million times more. And that's the problem with it. And then what happened is when all this level of DDT built up in these birds, one of the effects it had is it reduced reproductive ability of the birds, and it also made their shells thin. And you should know this, that the thinning of shells due to DDT almost led to the extinction of many raptor birds, including the American bald eagle, which was their national symbol. And that's, weirdly, that really woke everybody up. Like, what? Eagles? If it had been something else, maybe they wouldn't have done it. Okay, that's probably not true. Okay, well, let's talk about Mercury now. Okay, so Mercury is an element on the periodic table. I used to know the number, but I can't believe I forgot the number for Mercury. Oh, 80. Okay. Anyway, it turns out it's present in mine tailings. It's present in coal in small amounts. And coal is the problem because when we burn coal, we release it into the air. Remember, these are things that can travel a long distance. But the mercury, elemental mercury is, it's not good for you, but it's not that absorbable. But what happens, unfortunately, is it falls down and it gets into the water. And when it gets in the water, there's bacteria that take it in and they end up converting it into this here. And this is something that's really awful. It's called methyl mercury. And methyl mercury bioaccumulates and biomagnifies. Now, by the way, if you add an extra C, so it's instead of it being a single carbon, that's methyl. If you put in ethyl, but with two carbons here, that we actually use methyl mercury in things like ink for tattoos, or as a base for vaccines. Even we intentionally stick it into people, but ethyl mercury breaks down very quickly and passes out our body, but methyl mercury accumulates, and so methyl mercury tends to build up to very toxic levels in organisms because it bioaccumulates and it biomagnifies. So basically, it gets released from coal exhaust. It gets precipitated into the ocean. Once it gets in the water, bacteria in the water turn it into methyl mercury. Then it starts passing through the food chain, and we find is these apex predators just have large amounts of it in there, and it causes a number of problems, including neurologic problems, and so. And we're talking here, like we're talking about Inuits. We're talking about people who live far, far, far from where this is happening. That's the problem with POPs, is they can travel long distance. Actually, this isn't a POP. This is just an industrial pollutant. It's not an organic one. Let's just talk about some of the effects that mercury has on people. So the main problems with mercury is the effect that it has on our nervous system. So it makes it difficult for us to move. It makes it difficult for it to hear, to talk, to think. So it is a very, very powerful neurotoxin, and it tends to have profound effects, especially on developing embryos, fetuses, and young children. So the earlier in life you get exposed to, when your brain is developing, you end up with these lifelong problems. And the most tragic one, we talked about this already before, was Minamata disease. So in Minamata Bay in Japan in the 1930s and 40s and 50s, this company was dumping mercury compounds into the water, but the bacteria in the bay converted that mercury into methyl mercury, which then got taken into by zooplankton, then taken into shellfish. People ate the shellfish. It even got more magnified when it got up into higher trophic levels. So when people caught fish, so people who got their food out of the fish and shellfish in the bay, suddenly they had really significant problems of neurologic effects, which are called like tonics. So they couldn't move their bodies. They had intellectual disabilities. It was just truly tragic. Thousands of people died, and many thousand people were affected. It was horrible. Now, another similar one we'll finish up here is tetraethyl lead. And you should know about this one too, because this is a success story. So, tetraethyl lead was an additive. When I was a kid, we just put that in gasoline. So, we had gasoline was leaded. Tetraethyl lead was able to cause lead to, it was called anti knock. It basically let lead burn better in a less explosive way. Okay. But the problem was it came out of the exhaust of cars, and then the rain carried it into the soil. So it got into the soil, and once it got in the soil, it got accumulated in the roots of plants, and then it gets into the groundwater. So people are drinking it in. The cattle eat it, and it becomes incorporated into the tissues of the cattle. It's fat soluble, and so then the people who ate the cattle, people who ate the plants, they just started accumulating lead. Well, the problem is this: people aren't having acute effects. It's not that much that they're getting, but it does a few things. It causes like anemia. That means an inability to make red blood cells. It causes heart and kidney disease. But here's the most tragic thing about lead: there's no level of lead that's safe to have in you, and lead has really profound effects on neural development. So children in utero, infants and young children who got exposed to lead, the problem is that they end up with decreased intellectual capacity for the rest of their lives, and to the point they may not even be able to be independent. And another really, really weird one. You will not believe the graphs I'm about to show you, but I mean, it's been shown all over the place. It seems that lead exposure in children, and that could be like monitored. Like you take blood samples of children, they go to the doctor, and they could find the amount of lead in it. It tracks amazingly with data from violent behavior that the police departments require. Look at this. And you see this from basically every developed country. Here's what we've got. Okay, so this here is the amount of lead in people's bodies, in school-age children's bodies, as determined by doctors. And you see there's this hump. And this is, here we're in New Zealand. Here we're in Great Britain. I'm just going to follow the black line. Here we're in Canada. Here we're in Australia. Okay. So, I mean, you see this in America. I'm sure you see it in Korea. Now, this is violent crime. And look at the trends in country after country. The trends are the same. When they stopped putting tetraethyl lead in gasoline, the rates of violent crime decreased. The more lead they put in gasoline, the more violent crime there was. The less they put, the less. Now, this is correlative. We don't have a causality here, but it's a pretty profound correlation here. Anyway, so that's POPs and bioaccumulation. Thanks for watching. And now I got to figure out how to turn this off. Now I got this new way of doing it I don't like.